Hey guys, happy Friday. We're gonna do one more lesson of solving systems by graphing. Uh, for this particular lesson, we are going to use Desmos, and Desmos is gonna help us graph all of these, especially because we're gonna add a new type of function, and that's quadratics, just to show you that the intersection of two functions is the solution to the system of equations. So let's get started. But the same rules as yesterday apply. So here in our first example, we have a linear function and a quadratic function. All right. And so once again, graph the first one. The first one is quadratic. That's that upside down U shape. That's a quadratic function. That U shape is called a parabola. All right. So we have a parabola, and then we have our linear function, 6x minus 3y equals 3. So we need to know the difference, which one's quadratic, which one's linear. And we got two intersections, all right? So the first one I'm spotting right here at 0, -1. And the second one, I'm seeing it at -4, -9. And so basically what this means is this system has two sets of solutions, all right? So let's get right to it as far as verifying algebraically that they are. And they're always gonna work out, but we wanna just verify, all right? So my first solution again is 0, -1, all right? Which means that if I evaluate and that's, of course, x, y, right? That if I evaluate these functions with 0 in for x and -1 for y, we should get true statements. So let's check it out. All right. So I am going to go, well, y equals, instead of saying y equals, I'm going to say -1 equals negative quantity of 0 squared minus 2 times 0 minus 1. All right. We're just checking it out. And let's work with the 0 squared is 0 times -1 is still 0. -2 times 0 is 0. So I end up getting 0 plus 0 minus 1. In other words, -1 is equal to -1. That gives me a true statement. That means that this solution works, at least it works for this one. All right. Now we got to verify with our linear. All right. So our linear function is 6x minus 3y equals 3. So again, I'm going to evaluate. Instead of saying 6x, I'm going to say 6 times 0 minus 3y. Instead of saying y, I'm going to say -1. I'm going to substitute a -1. And I'm going to check to see that that is equal to 3. Well, 6 times 0 is 0. And -3 times -1 gives me a positive 3. So I get 0 plus 3 equals 3. Well, 0 plus 3 is 3. So yes, 3 equals 3. So check. That is the solution to the system of equations. All right, and there's a second example right there that you can take a look at with Desmos if you have the file. All right, but I want to say one last thing about graphing these. Okay, so graphing these can be kind of a challenge. So you want to pay attention to a couple of key points. All right, with a parabola, the most important point I would say of a parabola is this guy right here, sort of the turning point right there, and we call that turning point a vertex. All right, for a parabola. That turning point is called a vertex. So when you're graphing these by hand, you want to always get that vertex at the right coordinate. This vertex is at -1, 0. And then after that, really specify one more coordinate, which for us, it could be 0, -1, right? I think right here you have the point 1, -4, right? Et cetera, et cetera. Looks like you have the point, is it 2, -9, maybe? Okay, around somewhere around there, and I'm in the way, right? But 2, -9 looks like it could be a coordinate. Okay, so again, specify the vertex, and then after that, find maybe 1 or 2 more points, such as -2, -1. All right, that appears to be a point, and stick with it. Right, that's how you graph a parabola. With a line, as usual, we try to find the y-intercept. You can find the y-intercept and the x-intercept, especially when it's in standard form, or you can find the y-intercept and locate maybe one other point, like this intersection, right? And 2 points is all you need to graph a line. So that should help out. The other thing that we can say about that is, once again, with standard form, we can look for our y-intercept by substituting 0 in for x and finding what y is. We can find our x-intercept by substituting 0 in for y, all right? And finding those points will give us the x-intercept and y-intercept. And once again, that's just a little advice to graph by hand. But as far as I'm concerned, you can graph these with Desmos and find their intersections. You will sometimes have two intersections.